Physics Bites,
a science podcast in English
by the students of Notre-Dame d'Ascension.
Hello and welcome to a new episode of Physics Bites, the English language podcast of the physics students here in Notre-Dame d'Ascension in Paris. We are continuing our series this year with our final year students who have each taken a topic to talk about. And this year we have a new topic that we haven't seen in previous years, SETI, the search for extraterrestrial intelligence. And I have two students who have been with me for the last 3 years. And I have a co-host that has been with me for the last 3 years as well. So maybe we can start with you guys introducing yourselves.
Hello, my name is Victoire.
So we have Victoire,
yes.
And
Suzanne.
And Suzanne. And my co-host today is
Clara,
which we will hear talk about climate science later on in the series. So, as usual, how about we begin with you guys giving a short summary of what you talked about in this vast topic of search for extraterrestrial intelligence.
So first, I think we could define the topic, what is extraterrestrial life. So according to NASA, it's every life beyond Earth. But we can ask ourselves if it's more likely to be like ourselves on Earth, or is it a possibility to have like extraterrestrial life but with, I don't know, silicon, for example? Or
right, so is it similar to human life or is it something completely different?
Yeah.
So, what do you guys want to start with now that we've asked the starting question? Victoire.
On the presentation, we started by talking about astrobiology.
Mm-hmm.
So people who study extraterrestrial life, and they ask themselves many questions to try and find something.
So it's a rather new field of science, astrobiology. Can you give us an idea of what kind of questions they're asking these astrobiologists?
Are we alone in the universe? What could be what form of life could exist outside? Is it like human forms or other forms?
But more coming from a biologist point of view, right? So
yes.
Like asking a question like, if the sun of this planet is bigger or smaller with a different color, what color would be the planet life on that planet, etc., things like this.
Mm-hmm.
Okay, what else?
They try to use equipment and telescopes to observe phenomena in space and to see if there's something abnormal.
Yeah. What would be something abnormal? What would be observing something abnormal? Do you have an idea?
For example, if there is a change in the atmosphere, we could assume that there's a potential of life on the planet.
Okay.
But sometimes it's difficult because there are non-biological chemical reactions that could appear on the planet. And so scientists would think that there's a life on the planet, but it's obviously just a chemical reaction due to...
Right, so it's very difficult to define even what life is in that case,
Mm-hmm.
right? Like, how can we define life? Did you guys find anything in your research about how maybe these scientists try and define what we mean by life, if it's not looking like us, like, a head, 2 arms, and 2 feet?
We know that some of them are looking for bacteria.
Mm-hmm.
So they observe bacteria in extreme conditions to see how they react and if they can survive.
So like extreme conditions, like with no air, high temperatures,
Yes.
stuff like this, stuff that would be the case in maybe other planets,
Yes.
which are is a more violent sort of a setting. Okay.
Mm-hmm.
Do we have a definition of life that we can apply to anywhere in the universe? Like, what would be, search for extraterrestrial intelligence. So there's the word intelligence there, which is already hard to define.
Mm.
And now we're talking about life. What's the relation between life and intelligence? Is it the same thing? Is there a way of defining it? How can we...
I think life and intelligent life is different because maybe there's life, but they don't have the capacities to send us signals or to even know or to understand.
Yep.
So we don't even know. But if there was intelligent life, then that would be maybe easier because they would probably try and reach out
for us.
Right. There would
Maybe.
be a chance of communication.
Yes.
Whereas if it's just life, like
Life.
plant life, then it would be more difficult. So it's actually two different questions we're asking, right? The first question is whether there is life outside of the Earth, and then whether there is intelligent life outside of the Earth. Which one is easier to answer? Do you know? Would be
think-
theoretically, because we haven't detected neither one.
I think intelligent life,
Why is that?
because we would assume that if they're intelligent, they will try and ask the same questions as us, and so try and find solutions to send signals, to maybe see other types of life, and so to connect with us.
Right. So there would be an intention to look outside of where they live, so that would increase the chance, in your opinion, of having some sort of contact. Okay. Well, let's come back. Suzanne, you talked a little bit about the history of SETI, its creation, I think, by one of my own heroes, Carl Sagan. Do you want to talk a little bit about the history of SETI, maybe?
So basically, it was created for the search of extraterrestrial intelligence life. It was created on November 20, 1984. And when it was
So
created,
this was the SETI Institute, right? Which is a sort of a scientific institute with the goal of searching for extraterrestrial intelligence, right?
And when it was created, it wasn't very big. There were just a few researchers and scientists. But as the time passed, there were more and more. And I think nowadays there are around 100 in the institute. And they have more impact on this specific research.
Okay. So it's something that at the beginning, it was sort of very niche sort of thing, something that very few people were doing it. And I can tell you that even many scientists didn't take it seriously, and now it's being taken more seriously, right? So it's being considered as something that we do have to think about and sort of research, and there's more funds going into it. Okay. I remember at one point in your presentation also, you guys talked about the philosophy of SETI. Maybe we can talk about that before we go into some other questions that Clara found from your classmates. So what do we mean by the philosophy of SETI?
So by the philosophy of SETI, we mean does it even make sense to look for extraterrestrial life? And we yes, there are many points of view, whether it's useful, whether it's dangerous for humans to search for other types of life because maybe it can be harmful. I think, for example, Stephen Hawking, he believes that it's a bad idea because it could be dangerous for humans to actually, because these other types of intelligence could be superior to us, and so they could be harmful, for example.
Was a danger to us? Okay. What about the religious side of things? There must be some interaction between the idea of searching for extraterrestrial intelligence and maybe how religious thought might clash with it. They go together. You guys had a very quick mention of that in your presentation as well.
Yes, we mentioned it because I think we said that if we base ourselves on the hypothesis that intelligent life could exist, they might be superior to us. And so on the religiously, we think that God would have created humans as himself,
in the image of himself,
in the image of
or
himself.
itself, right?
But then if there's other superior beings, then we don't know what the relation between God and humans is, and
so it would create a sort of a conflict between our religious beliefs and the reality that we would observe at this time.
Yes.
You had a really nice sentence to finish off your presentation. It was, I think, your point of view talked about the desert. Do you remember what you guys said? I really like the image. So do you want to maybe share it with us?
Yes. There was also one thing that was maybe we haven't found anything because we are too small and we are in the wrong side of the universe. And so we made a comparison with the Sahara Desert. If we put one person in the middle of the Sahara Desert, he will think he's alone on the earth, but it's just that he's located on the wrong side and he's too small, so he can't really take a step back and see that.
So for him, it's what he would be asking, why is there a whole planet with just me on it, right? Whereas there's billions of other people. It's just that you
don't see it.
You don't see them, and you're not in a place to see them. I really like that analogy that you guys use, right? It's at the same time kind of optimistic. And at the same time kind of depressing because we are in a way stuck in the desert and we have no chance of At least with our lifetime and our technology, it would be very difficult maybe. Which also comes in contact with one thing that everybody sort of has heard about at some point or another. But before that, let's talk about the Fermi paradox. What is the Fermi paradox?
The Fermi paradox, I think it was said in 1950, and it says that we know that there are a lot of stars and a lot of planets in the universe, but we haven't found any with life. So the paradox is that there are so many, but we haven't found any. So even though the probability is probably not zero.
Right.
So that's the paradox.
Okay. And then so from there on, you moved on to the famous Drake equation. Suzanne, do you have a short bit of information for us about what we mean by what is the Drake equation? Who was Drake? What it's supposed to tell us?
An equation based on specific components that would be able to calculate the amount of extraterrestrial life in the universe, and so it will help us to estimate the numbers they could be around the universe, and so how we could.
So it's a way of approximating.
Yes.
How many civilizations or intelligent civilizations there could be? What were some of the factors that are taken into account in the Drake equation? How does he go about his approximation, either of you guys?
So, I think, first of all, he was it aims at calculating the number of habitable planets suitable for a form of life in a certain volume of the universe. That was the first part of the equation. And so to calculate that, they calculate, for example, the fraction of stars close to the universe.
Right.
Then the fraction of those stars having habitable planetary systems orbiting around them. Then the number of planets per solar system with an environment suitable for life.
Right. Notably an atmosphere,
yes.
Which would be necessary.
So that was the first part, and then I think the point is to calculate the likelihood of technological species arising on these planets.
So each time we start with okay, let's take out of all the planets and the stars, what percentage can have this criteria which is necessary, and out of that, which percentage is going to have a smaller and smaller. Very approximative, but. Is there a number that comes out of the Drake equation? How many civilizations we should have?
Frank Drake estimated this number at 10,000 civilizations.
Which is a lot of civilizations, right?
But it's only based on very vague approximations.
That's exactly it. Still, it gives us hope that there has to be some sort of extraterrestrial intelligence out there. I guess the rest of the question becomes a sort of a question based in astronomy, whether we can actually get there, we can observe it or not. So, okay, well, maybe we can move on to some of the questions, because there were a few questions. Clara, do you remember maybe some of the questions that your classmates came up with or were curious about, or maybe yourself when you were reading this? Did you have any particular questions?
So, there was a question from Jeanne. So, are we sure that our machines cover every narrow bands?
So, the narrow bands we're talking about is narrow bands of from radio waves that we capture with our radio telescopes. What did you mention about the radio telescopy, about these narrow bands? Maybe you can come back to that and then you can answer the question.
So, we were saying that radio waves could be a way to communicate with an intelligent extraterrestrial life, because we know that there are a lot of objects that produce radio waves, and so if it was an artificial radio wave, as each radio wave has a specific frequency, if it's an artificial one, we could see that it's not the same frequency as the ones we have.
Right. The idea, I guess, being that there are some phenomena which are natural, and which have certain frequencies in terms of the radiation that they create. And there are other ones where we would never see these kinds of frequencies. So if we do find that, then it has to be something that's made by some process other than a natural.
Yes.
Right?
It's when we take a radio and we want to tune in to a very specific radio station. Well, we have to pick a very specific frequency. So that's kind of the same thing. And so narrow bands, it's very small frequencies that could be specific of a certain
electromagnetic radiation.
Okay. And in linking to that, I think there was a question
Yes.
about hydrogen.
It is the idea of a hydrogen is that it's a way of saying that we know hydrogen is the most abundant element, and so sending signal at its frequency.
Right, because so we come here to the question of how would we communicate? Let's assume there is some sort of an extraterrestrial intelligence. How would we communicate to them that and show that we exist and we know about things that you might know about, right? We need to have common things to talk about. So how does hydrogen play a role in that? That was the question.
Well, hydrogen is one of the most abundant gas.
But the most abundant. 80% of the universe is hydrogen, right?
Gas in the universe. And so we know that its frequency is like 1,400 and something, 20 I think, megahertz. Mm-hmm. And so being an intelligent civilization, we know that.
Right, that's something you could know only if you have studied and have a scientific understanding of the world, right?
Yes.
Okay.
And so if we send hydrogen like
waves at that frequency,
it would maybe mean that we are intelligent and that we are here and that we're trying to send a signal, and could be like a rendezvous point.
At least a sign that there is something, somebody, some civilization out there to say that. So the idea being that, for example, if we suddenly start capturing these radio waves coming from one particular place in space, and the frequency, we look at it and we're like, oh, that's exactly the frequency for the resonance of hydrogen atoms. Then we're like, okay, that can't be a coincidence. Then somebody's doing this on purpose, right? Yes. That's the idea.
So there was a question linked to that subject. So what are some ideas for how to communicate with an extraterrestrial intelligence? Is there any such thing as a universal language?
Right. So let's generalize this question to, okay, so hydrogen, the frequency of resonance for hydrogen is one thing. Is there anything we can consider as like a universal language? How would we communicate? This is the main problem, right? Mm-hmm. Any ideas?
I think there was also the questions of exoplanets, because they represent a potential of life. Mm-hmm. With the telescope, they would try to capture the molecules,
like get the spectrum of the atmosphere and get an idea what it's made of.
And so with the dips, they would calculate which molecules is on the planets, and with that they could base their theories on if there's someone in the planet.
Okay, but I think the question that Claire was asking was more about communication. How can we come up with a language, not a language like English or French or Spanish, right? But a way of communicating that even somebody who's very not human could understand it. What would be a good candidate for that?
Is there a good candidate for that?
That's a good question. I have an idea what might be a good candidate. I'm wondering if you guys think there would be one.
I don't remember the name, but I think there's like a language, like a sort of code language.
But that remains very human languages, right? What can we use?
Computers? No.
Well, computers could help us with it, but the idea being mathematics, right? Mathematics is not something that's only human, right? It's something that's a property of the universe, or so we like to think, right? And so one of the ideas that Carl Sagan had, and he used this in his book, which was turned into a movie called Contact, was the idea of prime numbers. Prime numbers. To know what a prime number is, you need to have some sort of a mathematical culture. And so in the book and in the movie, suddenly we humans on Earth start receiving these signals which come in bursts that follow the prime number. First there's 1, then there's 2, then there's 3, then there's 5, then there's 7, and so on. And we're like, okay, there's no possible way that a natural phenomenon can create just bursts that are following the prime number sequence. So I don't think there is. It's very difficult to come up with anything that would be a universal language other than something as universal as mathematics, maybe in the end.
And I think also in radio waves they talked about modulation in radio waves, because we know that
that's how we do radio waves, right? That's how we send AM and FM radio. So the idea being what?
If there's a modulation, that means there's a message. So even though we can't decode the message, we know there is a message.
There is, again, some sort of intention, some sort of intelligence behind this. That's very much it. And again, in the book or in the movie, we have the idea that so Earth started transmitting radio waves in the 20th century. And so they go out into space, and at some point they reach an intelligent life, which recognize it that this is modulated waves, and they send it back to us as a way of saying, oh, we heard you, right? So again, modulated waves, if we catch it somewhere, it's a sign of somebody, not a natural process, something that's artificially manipulating a natural phenomenon. Clara, I think you had another question.
Yes, but if there's not that knowledge of mathematics and prime numbers, do you have any idea of how we would translate that message if it's in a completely other language? Do you have any?
Not an easy task. I think it's a
I think first if we prepare them, that's already a big step.
Yeah.
Then trying to.
I think it would depend maybe on the nature of what we're detecting, right? Is it biological? Is it physical? Is it radio waves? Something like that. So you mentioned exoplanets. Let's talk about exoplanets, right? So what is the role that exoplanets play in our search for extraterrestrial intelligence?
Because they're like the potential planets for life.
Right. So to be clear, life can't exist on a star.
Yeah.
It has to be on a planet or something that's not as hot as a star, right? So the fact that we have started discovering many, many exoplanets the last 20 years is a big boost in our search for extraterrestrials. So how are we dealing with these exoplanets? There's thousands of them that we have discovered. How are we using this information to try and maybe...
Because I think first the scientists created like the habitable zone of the exoplanet. So if it's too close from a star, it would be too hot, and so the water would evaporate and the air condense.
Yeah, exactly.
And if it's too far from the star, it would be too cold, and so if there's water on the planets, it would be like sort of ice, and so it wouldn't be the best conditions for it. And so they determined the habitable zone, and for example, in our solar system, I think it's from Venus to Mars,
right,
perfect habitable
in terms
zone.
Of not too hot, not too cold, right?
And so the Earth is, of course,
and Mars is, we have been trying to see if we can find traces of life or what remains of a former life on Mars, because that remains the closest candidate for a habitable planet.
But the problem is that we assume the conditions of life elsewhere are our own conditions in terms of need for water, temperature, etc. How can we know these are all valid for any kind of life, even forms that we cannot imagine? Yeah,
so this is the question, because you mentioned, for example, the famous, what we call the Goldilocks zone, right? The planets which are just in the right spot for water to be liquid. Does water have to be liquid? Do we even need necessarily water for the presence of life? Do we need carbon?
I think we think of water first because our life is based on carbon and water, and so of course we're gonna put our researches through this way. But some scientists assume that there's other forms of life that are not based on carbon, like Earth, and so for example they found out like a sort of life based on silicon,
right?
And this atom, which is close to the carbon one, is better through an acid condition.
Acidic conditions.
Concentrated sulfuric acid.
Yeah.
And so perhaps it could be a life that is developing.
Right. So I think there are some similarities necessarily, right? So silicon, or as our British friends would call it, silicium, or like we do in French, it's still similar to carbon because it still can form 4 covalent bonds. And the reason carbon is so essential for life is because the fact of forming 4 covalent bonds, it allows it to make a large variety of molecules, which is what we need for life. The more different types of molecules we can have, the more complex molecules we have, the more we can have life. So it would still have to be something that's similar to life on Earth, same types of reactions, even if the conditions would change. So I guess in a way that's good, because it's not like we're saying anything is possible. Yeah, many things could be possible, but there are some things that are more likely, right? I don't know, Clara, do you have any more questions on the science part of it? I think we can maybe talk a little bit about the philosophical aspects of some such a thing if you have no more questions.
No, it's okay for life.
No? What about you guys? Do you guys have any particular things that you discovered during your research which you want to share that were particularly interesting on the scientific side of things, whether it's discovery or off the top of your head? No? Nothing comes to mind?
Well, I was surprised because I did not know a lot about the subject, and I was surprised that we didn't find anything, like nothing.
Are you disappointed a bit?
No, I'm optimistic, but I was, surprised.
Okay.
Yes.
It is a very short time that we have the technology to look for this, right? I mean, telescopes we've had for many years, but really powerful telescopes is recent. Radio technology, electricity, it's 100 years basically that we've had this, right? So we as a civilization are quite infants. We're very young and we just started having science in any kind of a realistic way, right?
But I think it's developing more and more and really fast, so...
I think it's interesting that before, like you guys mentioned, this wasn't taken too seriously. This wasn't taken to be really scientific. And now we're not discouraging young scientists for going into this kind of a field, right? Which is already a kind of an evolution compared to the time when Carl Sagan came up with the idea, or at least put it into action. So maybe we can take a little short turn before we finish. Think about the philosophical stuff, because there is a lot of, I think, interesting ideas behind the search for extraterrestrial life, right? So first of all, in your opinion, does it help us know ourselves better when we look for extraterrestrial life? Like, does us as humans, what does that tell us about ourselves, maybe? About the origins of life, maybe on Earth, or...
Well, maybe it tells us that we are not the center of the universe, and we're not the center of everything if there's other forms of life.
Is that a good thing or is that a bad thing?
Well, it depends for whom, but I think it's a good thing because we have to open up and to see.
So imagine, let's think of a hypothetical situation. Imagine suddenly tonight we have some scientists that discover something, and in 6 months we have definitive proof that there is life in the universe. How would you guys feel about that? How would that affect you? Would it change anything for you?
I think it would be incredible to think that there is a real life beyond Earth. And I don't know, I think I would be optimistic about it.
I think I would be scared because we don't know what happens. Like, okay, there is, but how, like, are they mean people? Are they gonna attack us? But we don't, because we don't know anything about it. So I think on the one hand I would be surprised and happy because it's a huge discovery, but then on the other hand...
Do you think it would change anything in your way of looking at life or in your behavior in your daily life, or no?
I think
Suzanne?
if we don't enter in contact with them, it would be like just sort of a scientific fact, and I think we wouldn't
be impacted.
You don't think that there would something that would change? So let's look at the comparison, right? So for example, we often compare the Copernican revolution as being an event that really shook humanity on a sort of like epistemological level, right?
Yes.
About our vision of ourselves. It was one of the first confirmations that we are not at the center of the universe. That was the reason why there was so much maybe religious resistance to it. But it doesn't change anything in our daily life, right? The fact that the Earth is going around the sun or not, that doesn't change, some poor guy who has to work in the fields or you have to go to school. But it does change something in the long run in a way, right? It changes our vision of the world. Would this not be something similar? Do you think, is it comparable or?
I think it is, because then it would mean that maybe all the science fiction movies that we didn't think were real could actually be real and could actually be, yes, I mean...
And so, okay. And there would be science fiction. It'd be just science now.
Yes.
All right. Do you think there is a real danger if we find extraterrestrial intelligence? Realistically speaking, what would be the danger?
I think the first danger that comes up to my mind is like if they're more advanced than us, they could, I don't know, attack us and...
But why would they do that?
I don't know.
Let's go into speculation.
Because
So let's do the analogy again, right? You as a human are much more advanced than most organisms on Earth. Do you just attack them because you're more advanced?
Maybe we need things that their planet has. So, for example, they don't have any plants and they need all the trees from the Earth.
Do we have that many trees? If they're that advanced that they have detected us, but we can advance them, or if they're more intelligent and more advanced than us, do they really need our trees?
Probably not.
No?
Yes.
But like, for example, with the ants, they're just like going around under our feet, and we are just like smashing them.
But those are accidents, right? You don't go. Very few people on purpose are going around like exterminating ants.
It's true, but like it could be a possibility.
It's interesting that you bring up the question of ants, because that's kind of what I was thinking about. In that, we are much more advanced than ants. You don't think about ants in your daily life, right? You walk past them, and you don't even pay attention. So could that not be true? Maybe there are many extraterrestrial intelligences out there. They're so much more advanced that to them, they don't really care. Right? They're just doing their thing. They're changing galaxies and stuff. And here we are still debating whether we're putting carbon into the atmosphere or not, right?
And we're trying to enter in communication with them, but maybe they know we exist, but they don't care.
They just don't care. That's maybe the most safe, at once optimistic and pessimistic way of looking at things, right? Okay. Well, I think we've gone through most of the stuff that you talked about. Is there anything you want to add that we didn't maybe mention that you felt strongly about in your research, in your presentation? I think
we can finish on an optimistic
let's do that.
I wanted to share with you what Seth Shostak said. So he's an astronomer at the SETI Institute.
Okay.
And so he said that from 10 to 12 years, the number of stars on our system, of star systems that we will have checked out looking for signals will be more than 1 million. So we will probably find something.
So he's convinced that we are going to find something within the next few years.
Yes.
All right. Well, let's hope that Seth is optimistic and well-founded in reality. So thank you very much for the topic. I thought it was very interesting. It's something that's close to my own heart. So I thank you to Clara for being such a wonderful co-host. So we hope you enjoyed the episode, and we'll talk to you guys next time on a new topic. Thank you, guys.
Thank you so much.
So that is Physics Bites for this week. We hope that you enjoyed the episode. Tell us what you thought about the topic in the comments section. If you did enjoy the show, then subscribe to our podcast, tell all your friends about it, and leave us 5 stars. And most importantly, come back soon for a brand new episode.